All right, so here we go with 8.4 notes. Our goal today is to solve log equations. Now you might remember we actually started doing this kind of stuff because we were evaluating logarithms, and you guys had to do that while you guys were graphing in 8.3, along with we had quite a few problems on the first assignment where you were just evaluating log equations. So let me show you what those actually looked like. Those actually looked like numbers 5 and 6, where you just had to convert and then use previous information. So we'll get there, but there's other situations where maybe we're not setting it equal to x, but instead x is going to be our base, or in these ones x is the base, or in these ones you're actually finding, you know, the of part of log, or log base 36 of x. Okay, so that's what you're going to find. So I'm going to show you how you are going to solve all of these today. So the main thing, and I have, said this in every lesson, is you have to know how to convert, because logarithms are foreign to us. They don't make, you have to convert them to understand what it is saying, because you guys are much more familiar with exponents than you are logarithms. So if we go to convert this, our base is 36. The exponent is what it's equal to, the 3/2, and that has to equal x. Well, you're already done in this case, because when you did this, x is now alone. All you have to do is plug in 36 to the power of 3/2 into your calculator. So it's going to look like this: 36 to the power of 3 divided by 2. Make sure you use parentheses there, unless your calculator actually has that little box that you're putting the exponent in. So 36 to the power of 3/2. And what you'll end up getting is that x is 216. So the hard part here is just knowing that we have to convert. And once you get that, x is already by itself, and it's as easy as that. All right, for number 2, same idea. You just want to convert. So 16 to the power of 5/2 is equal to x. Again, x is already by itself as soon as you convert. So if it's that of one, it's awesome, because as soon as you convert x is alone, you use your calculator again, 16 to the power of 5/2, and you will have x equals 1024. And you're done there. All right, so number 3. When it is the base, what we're going to do is, again, you're going to have to convert. There's really no other option when we're doing these. So we have x to the power of 2/3 is equal to 25. Now the problem is you have to get x alone. So, all right, now in order to get x by itself, you're going to have to take it to an exponent. So the exponent that you are taking it to, you eventually want x to the first power, right? Because you want it to be by itself. Well, if you are taking it to another power and the powers are multiplying, the power that you want to take it to is going to be the reciprocal. It has to be 3/2. Since you do it to one side, you have to do it to both. Now, the reason why is because when you multiply these two together, okay, so here's just, you're off to the side, 2/3 times 3/2, you get 6/6, which is 1. When you multiply reciprocals, you're going to get 1, which is why you have to take it to a power of the reciprocal, so it turns into x to the first power equals, on the right side, you just have 25th to the 3/2 power, okay? Now since x is alone, technically you did not have to put that to the first power there, but x is by itself. All you have to do is plug in the right side into a calculator. So now the calculator work happens, and you're going to get x is 125. That's what you get. All right, let's try number 4 then. So you have convert. Start by converting it. X to the power of 5/2 is equal to 243. And then again, you're going to, in order to get x by itself, you're going to have to take it to another power so that we can create that power to be 1. So what power would we take it to? 2/5. The reciprocal of 5/2. So on the same on both sides. Now this turns into 1. So we have x to the power of 1. I don't need to write to the power of 1. Is equal to 243 to the 2/5 power. Put that in your calculator. You should get 9. All right. Now, these are ones you guys have already done before, so I'm going to show you how you've already done them. As soon as you go to convert, you have 3 to the power of x equals 1 over 243. Okay. If you're trying to solve and it is an exponent, you have to have the same basis. So here, again, that fraction might throw you off, but really it's nothing. You just want to look at the 3 and the 243. So look at your powers chart. How can you write 3 and 243 with the same base? You're going to use 3. So this one's going to remain 3 to the power of x is equal to 1 over, this is going to be 3 to the 5th power. Okay. Now I don't want to keep that as a fraction, so I'm actually going to write this 3 to the power of x is equal to 3 to the negative 5th power, because I want to bring that up to the numerator. And now that you have the same base, x is negative 5. Like I said, this one you've already done it. You've done it in 8.2 and then again in 8.3. So this should be, you guys should be pretty good at this by now. So this one, again, you're going to start with converting. 32 to the power of x is equal to 2. You'll notice that everything that we've done so far, we have never done anything with a logarithm. We always convert it to an exponent. And you're just going to get used to knowing that you're going to convert it. So 32 to the power of x is equal to 2. We need 32 and 2 written with the same base. So look at your powers chart. How can you write 32 and 2 with the same base? You're going to use a base of 2. So 2 to what power gets you 32? 2 to the 5th power. So we have that is equal to, this one's just 2 to the 1st. If you want to write it to the 1st, then that might help you too in a minute. You're multiplying, so we have 2 to the 5x is equal to 2 to the 1st. Now that we have the same base, you can set the exponents equal to each other. So we have 5x equals 1, and x would be 1/5. And there's your answer. All right, let's go ahead and we're going to move on to the next page. Now, the next page is another property of equality. And this is when you have logs on both sides that you're going to need this. But you'll notice that if you have log base b on both sides, then what you can do is you can take whatever you're taking the log of, and you can set those equal to each other. So this would mean that x is the same as y, okay? Which is very similar to that property of equality that we used with the exponents. If you're taking the log of something and they're equivalent, then we must be taking the log of the same thing. And so all you're doing here is log base 3 and log base 3 match, so whatever we're taking the log of must be equal to each other. So we have x squared minus 15 has to equal 2x. Okay. Now, if this was just a linear equation, that would make it a little bit easier, but this is a quadratic, so we have to solve it like we did back in Unit 5. So in quadratics, you want to make sure that you set it equal to 0 in order to solve. Now, you could solve this using quadratic equation if you want, or factoring are probably going to be your easiest choices. I would just factor it if it's possible. So when you're just unfoiling it, one of them has to be a positive, one is a negative, because these two have to multiply to negative 15, okay? And when you FOIL it, your outside and your inside have to turn into negative 2x. So we need here minus 5 and plus 3, okay? And so what you're doing is you have x plus 3 equals 0, x equals negative 3, x minus 5 equals 0, x equals 5. Because remember, when you are doing this by solving by factoring, you have two things that multiply to 0. One of them must equal 0. Okay? Now, this is the part that a lot of people tend to forget, and it is to check your answers. And you have to do it. If you don't, you might have an extraneous solution that you don't notify is an extraneous solution. Okay? And what's an extraneous solution? Well, you cannot take the log of a negative number, because if you think back to our domain and our range when we were doing log base b of x, okay, your range, the y, was an element of all real numbers, but your domain was x is an element from 0 to infinity. So this number is not allowed to be negative because that's what we found when we graphed it. You'll never have a negative x value. And because of that, when you go to check it, you have to make sure that you're not plugging in a negative value into these logarithms. So we're going to plug them in. So log base 3 of negative 3 squared minus 15 equals log base 3 of 2 times negative 3. So here we're going to have log base 3 of 9 minus 15. That's going to be negative 6, and that actually turns into negative 6 also. So right there, that is not allowed, which tells you that negative 3 is extraneous. Okay, that's an extraneous solution. Now we're going to check it with 5. Okay. So log base 3 of 5 squared is 25 minus 15 equals log base 3 of 2 times 5. Come on, where's my mouse? There we go. Log base 3 of, this is going to be 10. And log base 3 of 10. I don't have to go, oops. Sorry. I don't have to go any further than that. I can see that that's the exact same thing on the left and the right, and that this is an actual solution. Okay, so we need to make sure that we make note of what is extraneous and what is not there. Okay, so this one here is an extraneous solution, and that one is an actual solution. I'm going to write this up here because that's why we have to check, because we have to make sure that there's not any extraneous solutions. All right, so this one, same idea here. When you see that you have log base 5 and log base 5, awesome, we can go ahead and we can set x squared plus 10 equal to negative 7x. And then from there, we're just going to solve. So again, this is a quadratic, so you want to set it equal to 0. X squared plus 7x plus 10 equals 0. I would try factoring first. It's a lot quicker than quadratic formula, but if you love quadratic formula, you can go for it. They're both going to be positives because it multiplies to a positive number and adds to a positive number. So 5 and 2, x plus 5 times x plus 2. Set each of those factors equal to 0 to get our two solutions. And then we can't guarantee that those are going to work. They might be extraneous. The one thing that some people do is they automatically see that those are negative numbers and they're like, oh, well, when we get negative numbers, those are extraneous, right? It's not if these are negative. It's if you plug them in and you're taking a logarithm of a negative number. That's when you can't do that. Okay, so we have to check this. All right, so we are going to check. And the first one that we are going to check is x equals negative 5. So log base 5 of negative 5 squared is 25 plus 10 equals log base 5 of negative 7 times negative 5 is positive 35. Log base 5 of 35 equals log base 5 of 35. And you can see that obviously those are equivalent, so that works good. And you're taking the logarithm of a positive number, so that also works. So that is a solution. Let's go ahead and we're going to check negative 2 next. Log base 2 of 2 squared is 4 plus, or I'm sorry, negative 2 squared is 4 plus 10 equals log base, I'm saying by base 2, this is base 5, sorry. Not that it really matters in this case, just that they're the same. So log base 5 of negative 7 times negative 2 is positive 14. This also is going to get us 14. And we're taking the logarithm of a positive number. So actually both of these solutions will work. Now sometimes you only have one extraneous, sometimes you'll have two extraneous, and sometimes you'll have none like we did in this case. Other than that, I mean, you'll just make sure to be checking the way. Lulu, that's enough. You'll know when you have to solve by this way is because you have logarithms on both sides, okay? So unlike the first page when we were converting, the logarithm was only on one side of the equation versus on both, like on these ones. So that's kind of your hint. Go ahead and try your 8.4 assignment. Let me know if you guys need help or have any questions. Hope all is well and have a good day.